Welcome back. This will be the third video in the Lugols solution. We have graphite graphite electrode, pure graphite. It's 2mm thick. Got damaged in shipping a bit. It's only wrapped in foam. The negative electrodes got carbon felt attached by cable ties and zinc coated. You can see where the zinc plating was left at. This time it was zinc coated in vinegar and distilled water, nothing else added, and 2 zinc electrodes. It's about 4 hours coating. It's a different coating. In fact, the hydrogen bubbles, I think, are still in here from yesterday, just sitting there. Well, they're flammable anyway when you knock them and they come up when you light them. They're very clear. It's over 24 hours. I think it's reacting with the zinc particles in solution and the vinegar. And the positive one's just the same. Graphite plate and some felt. It's 35 by 40. I'll assemble the cell because it needs to be in a sealed container because it evaporates a bit and I don't have much solution. I've only got that bit, a little bit in the bottle, and 100 mils. Alright, I have the cell sealed. I just used hot glue around the electrodes. I lifted the negative one up a bit higher than the positive because stuff sort of settles a bit. So positive side's marked, negative side's marked. All I have to do is add the electrolyte, which is Lugols in the background there, and that bit. Alright, I'll add the electrolyte and I'll get back. Alright, electrolyte's in, but it's not reading high voltage. Like previous times when I added the electrolyte, it shot up to 1.3. It's only 0.2. I bobbled the leads. So I'll give it a charge and see what happens. I'd still think it would register a voltage. On charge, 1.5 volts, 600 milliamps. That's drawing a lot more than last time. I'll let it go, see what we get. I'll give it about an hour and a half, 2 hours. Cell's been charging for 1 hour. Disconnecting. No, doesn't look like it's a working cell. Wonder if they're touching. Alright, it's the next day. Something very odd with this battery. The cells, if you can see that. Really hard to see on camera, but they're not touching right. So we have the positive, the negative. We don't have a voltage at all. Reason is I have this connected piece of zinc which I made the liquid overnight so clear up. So we put the zinc in the liquid, get 0.7 with this one connected. We take this off, 1.2, that's how it should be. Saying this is a positive as well, but it's coated in zinc. See, if I switch that over, the positive's now on the negative, we get 1.2 volts again. So the cell's got an identity crisis with the negative plate. Even with a charge, I had it on charge last night for an hour. Didn't make no difference to that cell positive plate at all. The only thing I did differently was the carbon felt here was electroplated in zinc sulfate, where the carbon felt on this one was in vinegar, which we still have hydrogen bubbles in there 2 days later. So and I sealed the cell up just to make it so difficult to fix. What I'll do is I'll cut that away and try to get it out without killing it. And I'll move the negative plate a bit closer and see if we get a potential. But we don't, I'm gonna slip the original zinc plated felt back in there and see what happens. Then I might attach some graphite pads to either side of that so it doesn't eat the alligator clip, and give it a test. But very odd. You'd think even the graphite was coated with zinc, so it should have some sort of potential difference. That's what happens when you seal a cell before you test it. Okay, I cut the top off. I checked that one. I was using graph foil, but didn't get a result on that, but it's all oxidized, so probably can't. I just connected it to a charge. It's at 0.8 volts and it's like 190 milliamps. They're not touching. Wondering if it's too conductive in there or something with that much liquid. So I'll just disconnect the charge. I need 2 hands. Hang on. Just do that. Alright, it's at 0.2 of a volt and dropping. So I'll slowly charge it up and see what happens later. Got it back on charge, 270 milliamps, 60. So I'll let that sit there for a while and see if we actually can plate, because it has a bit more zinc in it now. That was the thing I left in overnight, the zinc. It's actually not that consumed at all. That little piece can run 200 milliamps for over an hour on that cell that size. If it fails again, we'll stick in that piece of zinc and see what happens. We'll just get an energy density reading from it. Or maybe we find out how long a piece of zinc in iodine lasts for. That could be a better video. Something wrong when I graphite plate, carbon felt, don't know. Probably have to repeat the experiment with some zinc sulfate electroplating. Oh, it's just dropped in milliamps now, look. 20 milliamps. We're going to up the voltage to 1. Oh, it's not drawing much now, is it? Very weird. Something odd. Now it's at 2 volts and it's 300 milliamps. Just disconnect this. What are we getting? Oh, we're holding one. Oh, we may have done something to the cell. Maybe I was too eager to pull it apart. That's 1.4 volts. Huh. Whoops. So maybe I had to introduce more. One thing on the negative one, the zinc was completely stripped off of the graphite plate on the back. Still at 1.4, may have fixed it. Just gotta add zinc first. Interesting. Wonder if I should attach a piece of zinc on the negative for a while. Some decisions. I'll see how this goes. I'll charge it up for a couple of hours and see what the state of it is. I was just thinking about the cell and what was going on. Maybe it just didn't have enough zinc on the carbon and on the graphite. It looked like it was coated pretty good, but it probably just a surface coat, like nanometer thick or something. So maybe better off putting carbon felt and the graphite pad with a piece of zinc in behind it to add some zinc to the cell, or I'll just dangle a piece in there and let it dissolve slowly if we don't get an improvement, because there's some zinc in there now, but not a lot by the looks. That's not really damaged, you would say. In that brief moment, it's getting darker. It's only like being 9 minutes on charge. It's 300 milliamps at 2.1. So maybe I didn't need to break the cell apart. I did try a charge earlier, but it didn't take until I pulled it all apart. Maybe I didn't try it out hard enough. Okay, the battery's been uncharged for an hour and a half. I've just disconnected it. It's at 1.3 and holding steady. So we'll give it a run. It's at 50 milliamps, cutoff voltage 0.5. All right, it's holding good. 1.2 with a load. So we'll see how it goes today, but I might give it cycles with the zinc plate until that's consumed to add a bit more zinc. So it went a lot darker in an hour and a half. So there's still not a lot of zinc floating around to plate up, but at least it's functioning now. I should have just left it all glued up because it's getting hot. It's going to be 36 degrees today. So I'll glue it back up later and then cycle it with that and take note of the cycling, and then I'll get back and see if it improves. The cell ran for 35 minutes, so 30 milliamp hours and 36 milliwatt hours. So I'll start discharging with the zinc plate and adding some more zinc to the liquid, and then I'll get back after that zinc's all gone, and then we'll start the test again. Okay, the piece of zinc is in, and we're going to start a new test. Didn't need a charge. Well, probably actually did need a charge. Wonder what happened there. Normally that works. Try again. Alright, might have shorted out. Seems to be working now. It's just sitting really close to the positive side though, because it's in the middle electrolyte hole. Alright, that would probably run for a while. Oh, just spiked. Just went up in voltage. Cleaning off the oxides. it's the next day. I let it discharge with that piece of zinc. So it's eaten a fair bit of that zinc away. It's pretty thin down at the bottom section. Down there, it's like paper thick. And that's the liquid zinc iodide now. I think it might be saturated with zinc. So I'm gonna set that electrode back up in a position and glue it, and then glue that lid. And then I'm gonna charge it for at least 3 hours and then see what we get for a run. So it's both carbon felt on both sides. Really difference in colour. So I'll get back and then we can see the colour change on a charged cell. Okay, the cell's been on charge for 5 hours and 23 minutes or something. There's a little bit of clear stuff just at the top. 5 hours. Alright, so disconnect. It's been drawing 227 milliamps. So we've got a great colour, except for you can see the zinc, I think, on the negative electrode just in front of the camera. Okay, the cell's at 1.39. Getting ready to start a test. 50 milliamp load, cut-off voltage 0.5 volts. Alright, let's see how long that actually lasts. Okay, 20 days later, the cell's had 20 charges. It started off running for 4 hours and 45 minutes on a 5 hour and 23 minute charge. Milliwatt hours, milliamp hours. And then we're sort of near it, not too bad. And then over here with the remainder 17, we got 3 hours and 45, and then we're slowly dropping down again. 2 hours and 56, 2 hours and 57. Average voltage is higher, so it's cutting off quicker. I'm just running the zinc electrode in the center hole just so I can clear it up to see what's happening in there. I could see this like sediment. I think it's sediment. So I'm gonna run it. It's only at 6 milliamps. It's just barely running, but it's clearing up the electrolyte, so it's turning into zinc iodide. That's a yellowy colored substance. So it's been running for 4 hours and 52 minutes. It's only like 6 milliwatt hours and 32 milliamp hours. So it is getting clearer, I can see in there now. So I still don't know what that sediment is, and is it bridging the two electrodes? It goes right across there, you can sort of see it. It could be pitting in the glass, but I don't know. Can't quite see it. So I'll let that get a bit more clearer. So to do that, you have to discharge it with a zinc plate to use up all of the chemical reaction. Alright, there's the Lugols solution, totally sort of discharged, having a zinc plate. You can clearly see at the bottom there's this sediment. So now, wondering if that's going to bridge. Is it zinc oxide or something else? Now that might bridge the two cells, so I'll charge it up tomorrow and see what it looks like and if it runs better. Another day with the electrode, zinc electrode just sitting in there. So it's clearing up, so it's dissolving the zinc, becoming more zinc iodide. And I think maybe the stuff at the bottom could be because that's a lantern battery electrode plate, zinc plate, which isn't pure zinc. Could be in this, maybe. So now we can actually really see the cells holding up. So I'm gonna start a charge again tomorrow. Okay, 24 days later. I was gonna do a 24th test, but the power went out while I was at work. Didn't come back on until over here. So it's only had about an hour of charge. So the results, the cell initially started off at, that's the charge time column, run time, average voltage, milliamp hours, milliwatt hours, number of charge number. So as you can see, charge time was 5 hours and 23 minutes, ran for 4 hours and 45 minutes, average voltage, milliamp hours was 239, and milliwatt hours. Going by the charges, it sort of goes up and down, but stays within 2 hours-ish. Yeah, and this is the last plot. Dropping right here, started dropping here. And the red one is when I made it all clear, adding a zinc plate so we could see at the bottom. And then yesterday's one could only run 30 milliamp load, but I ran it for 5 hours and 50 minutes. The voltage drop was 0.78 on connecting the 30 milliamps. Alright, so next video, trying out the fuel cell version of it. Got a graphite pad. It's going to have some graphite felt both sides, not coated this time. And the other pad and the little container. This is the bit, the chamber. The felt sits in there on that little lip, both sides. And then the carbon pad compresses the felt onto that lip until it's flush with the surface of this. And it's put in there using copper contact on the back of the graphite plate. I don't think electrolyte seeps through this. I haven't seen any absorption in this plastic stuff, or well, it's graphite plate, but I reckon this one's got a binder in it. You have to file them, see they're not like, see, it's not exactly straight. That's why I think it's not a plate. Okay, thanks for watching.